flywheel cover covers the rotating flywheel, which prevents the flywheel from being damaged, or in some cases, damaging someone or something else. A flywheel without a cover is a safety concern. It also assists in airflow to avoid overheating issues which can cause internal damage to the engine. The flywheel cover has to be durable and tough. The cover would require withstanding internal and external forces without fracturing or deforming, as this could damage the flywheel. Furthermore, it is important that the flywheel cover is easy to manufacture to keep costs low, as well as being lightweight to decrease the total weight of the engine. Both parts of the flywheel protector were made using sheet forming operations. Sheet forming is usually a second phase metalworking process. Part 1 was deep drawn, as cylindrical shaped metal objects are typically made using this method. The circular hole in the centre base of this part was evidently pierced, as this is the most effective process to remove small circular shapes from sheet metal. Alternatively, the shape could have been casted, however the piece does not show any signs of casting, such as a parting line, therefore we can assume it was deep drawn. The many holes in part 2 were also made using piercing in order to keep the sheet metal intact. Following this, it was bent into shape that was needed to fit the flywheel. Drawing is a manufacturing process that is used in the forming of sheet metal by punching the blank into a die. This process has been used to create the flywheel protector. Following the deep drawing process, the part has had a hole punched into it by applying shear forces to the part. The process for deep drawing a workpiece involves two basic steps. Firstly, the workpiece is inserted between the punch and the die. Then the punch presses down on the workpiece, plastically deforming it into the shape of the die. This process may be repeated multiple times with different die and punch sizes to create some shapes that are not possible to do in one go. The process for shearing a hole in the part is similar to the deep drawing process, however the forces act over a smaller area of the part, causing the material to break rather than just plastically deform. The piercing of a hole would have occurred after the deep drawing process, as it needs to be an exact circular hole. Performing this operation prior to deep drawing could result in certain deformations.